And for those of you who don't know me, I've spent a lot of time over the years in large file systems and streaming I/O, which has now turned into big data and archives. And what I'm going to talk about, because Steve and I, if I can get this on my belt, but I'm going to give up. Steve and I were talking last September about, well, what do you want to talk about? And I said, well, I want to talk about challenges for big data. And it dawned on me that the real challenge, and it's kind of great to go third, because they've covered a lot of the topics and a lot of the reasons for my talk, is the challenge for big data is going to be archives. And the reason it's going to be archives is we don't know what we don't know about the data. In the geophysical community, they save everything for a reason, because there are new algorithms that are developed years later to figure out things that they didn't know. And that's true in a lot of communities. So if you just look, and I'm putting up a lot of eye charts, but you can read this later, disk drives cost a lot of money. They use a lot of power. We all know that. We're not going to be able to store tens of petabytes, hundreds of petabytes on spinning disk. It's just not going to work. Too costly for power, not enough power in the country, not enough reliability for disk drives either. So if you look at disk drives compared to tape, just the reliability, you read this many bits, you get this many errors. So, you look at consumer drives, you look at enterprise SAS drives, and then you get into the enterprise tape environment. And I'm of the belief that over time, we're going to be migrating to enterprise technologies for large data, because when we get 100 petabytes, or an exabyte, or 10 exabytes of data, the current technologies are going to break down. And we're going to have that much data, and you're going to have that data yourself. And the premise I'm going to make is, those who own the data are going to own the big data solutions. You can't put it in AWS unless you're going to leave it there forever, because the reason is you can't get it out of AWS. So just take a 40 petabyte archive. And by the way, the largest single namespace archive that's publicly available today, which isn't that large, is 54 petabytes. So these are real numbers people are working with. HPSS just published that for ECMWF, single namespace at 54 petabytes. So if you want to move it over an OC192 channel, you're talking about 500 days, a year and a half. To move the data from one archive to another. So let's say you wanted to move from Amazon to Google because Amazon started costing you too much. Well, it's going to take you quite a lot of time. How many people have dedicated OC192 channels they can buy today at a reasonable price? Not a lot. So from a network bandwidth perspective, you're going to have to, you can't move this stuff around. It's going to have to be local. You can't push it up somewhere. The other thing is, those who control the archive are going to control the solutions and the resulting benefits. So just think about 15 years ago, I was working, actually it was 20, no, it's scary. It was a little over 20 years ago, I was working with some people in the genetics community trying to model chromosomes. This was actually a long time ago. And they said, well, the stuff in between the chromosomes is junk DNA. Well, it's not junk. And if they didn't keep that stuff, which they actually did in those days, a lot of them, and kept it in the archives, they wouldn't have it today. And they're having to migrate it forward. And there was a huge cost involved in that. What do we know that we need, and what do we know we need to keep? We don't know everything, and we're not going to. And the geophysics community has, as part of their budgeting process, at least the places I've worked with, the idea is we have to budget for the archive because the archive is critical. Because we need this data as we move forward. The weather community and the climate community, same thing. They budget for the archive because they've got to save everything, because they don't know what they don't know about the data, and they're going to have to move forward and do model validation. So there are industries built around these archives, and they budget for them. What I'm seeing, though, is as we move into big data, people are just not budgeting for this. They're not thinking about, well, what do we need to keep? What don't we need to keep? How are we going to budget for it? Oh, let's just throw it up into Amazon. Oh, let's throw it into Google. Oh, we got to encrypt everything. Oh, you know, we got to get it out because Amazon just now owns our data and they just raised the price by a factor of 4. So, yes, prices are going down today, but, you know, at some point, they're going to go up. Just from, you know, a competitive standpoint. Look what's happened to airline fares as we reduce the number of airlines we have. Reduce the number of cloud providers, and they own the data. I see the same kind of economic model. So the costs of disk drives are well known. The costs of the storage, and you know, someone talked about Kreider's law this morning, and the fact that, you know, things aren't increasing in density as much as they were 10, 15 years ago. As far as we know, that's going to continue. There's a great presentation by a guy named Dr. Robert Fontana looking at the areal densities of various technologies and where things are going and why, for example, flash isn't going to increase in density and replace disk drives, which if you go back to 97, lots of people were saying that. Even in 2007 and 2008, flash is going to replace spinning disk. That's just not going to happen. So you got to think about the economics of your data in these large archives and what's going to happen with them. Here's another challenge area as we grow, as I talked about the hard error rate a little bit. Those who own and maintain their archives and keep them safe from silent data corruption, from data loss, and that was talked about this morning when I asked the question, well, how many files do you lose? And it was hundreds. Well, we had some bad servers. You got to maintain the integrity of your archive. If you don't maintain that integrity, you're going to lose data over time, and it could be important data. So, though tapes last 30 years, you know, you put them on the shelf. The media, you know, they've proven that through aging mechanisms. The interface to that tape is gone in about 7 years in terms of the support for it. The software, maybe you can get 10, maybe, but the interface to the tape is gone in about 7 years. Take, you know, whatever standard interface you have, fiber channel, SAS, you know, if you go back 10 years, Fiber Channel 1 isn't supported. So you've got, from a budgeting perspective, unless you're on an IBM mainframe for these archives, you got to go from a budgeting perspective and plan migrations. And it's got to be part of your process. So some of the people I work with in the preservation archive community, like the Library of Congress and others, they're constantly budgeting that we're going to be migrating this data forward to new technology. Now, right now that technology is tape because from a cost, density, and reliability perspective, but it might be something else in the future. Who knows? But at least for the foreseeable future, it's tape. Silent corruption is a real issue. I'm going to make a plug for a tutorial I'm giving, but the slides will be online about architecting to prevent silent data corruption. It's one of the areas I've been working in for about 8 years. It'll be up in a couple weeks at the storage conference presentations. But these are things you got to worry about because there have been known, and I can go into examples if anyone wants to talk about it later, real silent data corruptions in archives where people have lost important data over the years. And on disk drives, it's even a higher probability, just given the design of the media. And it's going to be a bigger issue as we get into hundreds of petascales and having large namespaces, because searching through this and figuring out what you need to re-index is going to be a big issue. Good example, we have climate data for 40 years, climate data in terms of satellite pictures for 40 years that NASA has. Has anybody taken and pulled everything out of the archive and tried to do correlations between snowpack and monsoon, or snowpack and rainfall, or other climatic events that we have? You got to do things like, for every pixel, geolocate the pixel, normalize for camera resolution, all kinds of things. These kinds of things are coming, and if you don't have the archive and control it, you're not going to move the data around. There's a huge scalability challenge because if you, and by the way, in case you haven't noticed, there's a theme to my presentation from at each of the breakpoints is, you know, if you don't own the archive, you're not going to be able to scale the problem. So your organization is going to need to understand the scalability of archives and how that's going to impact you, both from budgeting and what you're going to have to do with it, and if you have to reread all this data and re-index it. Large namespaces are going to be critically important. You're not going to be able to have hundreds of file systems with, you know, a few petabytes in each file system as we go forward. Those kinds of challenges, there are people in the DOE community looking at it. There are people in other communities looking at it that are driving large data sets through databases. These large namespaces, as we know them in a POSIX world or in a REST world, whatever your interface is, are going to be really important because what I term as namespace leveling and balancing the amount of storage in the namespace is really a hard problem. And people are really challenged by that as their archives grow, and if they don't grow in a balanced way. So there's also an I/O performance challenge, and people talked about that this morning. We're scaling density poorly. We're scaling performance even horribly. So performance might be, you know, with SSDs we got a performance bump, but if you look over time in the last 30 years, you know, performance isn't scaling with density. And it's not going to, given the challenges we have. No one wants to pay for, you know, a terabyte interface to a storage system. It's just not going to happen. And we're not going to spin disks at, you know, we spun disks when I started in the industry at 3,600 RPMs, and woo-woo, we're up to 15,000 now. We're not going to spin, you know, and if we look at scaling of density at 80 megabyte disk drive on the Cyber 819 was my first disk drive, so everybody can date me. But we're not going to, you know, turn 3 megabyte channels into 5,000 megabyte channels. The scalability of storage isn't going to happen. So we need to think about that from an architectural point of view and plan for that based on we might need this data again. This did not show up well at all.
It's in the video, Andrew.
Right, the numbers did. Okay, so let's just, you know, I was looking at bandwidth per gigabyte of capacity, and when I started, for every gigabyte of bandwidth, for every gigabyte of capacity, we had 37 megabytes of bandwidth. That was pretty good back in. All right, I'm going to wait a few seconds.
I'll see if I can.
Yeah, we'll just go through the number. Earl, we'll go through the numbers. That's fine. Give it up.
There are bars there. I can see it on the monitor.
Yeah, there are bars there. But, I mean, you go back, you look at what we have today in terms of technology, you know, these numbers are going, you know, exponentially down, logarithmically, whatever you want to pick. You know, we're at a factor, huge factors, and the performance is going down. So we're going to have to plan for lots more storage devices to meet our objectives, and it's got to be part of your budgeting process. Of course, with a lot of big data, we got metadata challenges. If you don't know what you don't know about your data, then you've got to develop an archival solution that allows you to be able to get as much extracted as you do know, even if you're not going to use it. And you're going to have to index that metadata locally. You're not going to be able to take, you know, in AWS and say, oh, today I thought of a new piece of data I want to get and extract out of my seismic trace. And if I've got a petabyte that I got to go through at AWS, that's just not going to work to bring over the network. So bringing metadata back has got to be local. You don't have the bandwidth. You can't buy the bandwidth. There was a great John Massey saying from the 80s is, money can buy you bandwidth, but latency's forever. And if any of you remember that saying. And you've got to be able to house your data and house your archive nearby your compute power, because you're going to have to bring things back at some point, whether it's for migration to new technology, or whether it's I've got a new idea that I want to experiment with and figure something out. If it's far away and high cost to bring it back, you're going to stifle innovation. And unfortunately, against everyone, in my better judgment, people seem to think that outsourcing ought to be a goal for these archives, where insourcing ought to be the goal for archives, because it's your data, and the security issues of pushing something up into a cloud are still unknown. I mean, Google says, well, if you give me you get my data, I can index it and do whatever I want with it. It's part of their contract. That was a big issue for some people. They seem to be concerned with it, which means you have to encrypt everything before you send it up, and then you have to then read it back to ensure that Google hasn't corrupted your data with silent data corruption or anybody else. What do you know about how the cloud people, and ask any cloud provider to give you a guaranteed on your contract and say, I will give you this many nines of data integrity. Well, Amazon says they'll give you 11 nines of durability. I've never seen a definition of what durability means. So here are my final thoughts. Archives are the central point, or will be the central point, for big data. If your industry doesn't have archives for big data, they're going to, because there's no way you can spin everything, and there's no way you know everything. To be successful for archives, you got to plan. And it's got to be part of the budgeting process and not an afterthought, which is what archives are in many cases in many environments. The archive must be matched with the requirements. If you need to ingest a terabyte a day or 100 terabytes a day, and if you need to use data, and what about migration? You've got to think about, you're going to have to migrate it, and what if somebody has a great idea and learns something new about their data? You know, we've got, I'm probably guessing, 40 petabytes of satellite imagery from the 70s that we have for climate research. What if somebody wants to pull it all back and figure something out? And they want to do it over an OC3 channel. Well, I'll be dead before they get it. So, archive management, archive design, you've got to be careful. You've got to spend money and do it right the first time and think about it. And you've probably got to spend money again in 5 years, because things are going to change. And we change computer environments and computer architectures on a regular basis, but no one thinks about, what am I going to do with my archive architecture? And my belief is this is going to be the central point of the big data problem. And my last comment, if you own the archive, you can win. If you don't own the archive, you're going to be dependent on a third party. And ownership of your raw data is critical to your success. Any questions?
Thank you very much. Kevin.
So Henry, I've got 2 questions for you. First of all, what's your thoughts on the recent Office of Science Technology memo saying data paid for and generated with federal funds or public funds have to be shared and distributed?
I think that's really a good thing, but that doesn't mean that you're going to be able to download it all. I mean, because there's going to be too much data generated.
What about the whole idea of opening that up into a federated environment in some way?
That's over my pay grade as a slimy contractor, Kevin.
Oh, I see.
I mean, seriously.
And then metadata is an important part of all of this. And right now we have a lot of researchers and scientists and businesses that are putting together their own, what they think is important for the metadata parts. At what point do we start to bring the librarians and the others back in to help identify that
That's
information?
really, and actually that's a really good topic area. There's a group at the Library of Congress looking at wrappers around things for packaging. I can talk to you about that offline. We don't have any standards for packaging archives or archival, even reading between vendor standards between archives, and file formats are going to be a big issue as we move forward.
So I have a half joke, half question. So you tell me that, so researchers are my customers, right? And so I try to tell them about storage and the difference between cost of drives versus what is storage and archive in the end-to-end solution. And they tell me, well, I can go to Best Buy and buy a $50 a terabyte drive. So I'm beginning to have an office in Best Buy and just meet my research community right there. And you might as well have a conversation there. But do you have a magic solution to educate people that listen? Cost of drives is about 10% of the equation now.
I feel like Don Quixote trying to educate people. And I have not found a magic solution. I write a monthly column and try to explain hard error rates, silent data corruption rates, drive failure rates, and I haven't been fully successful.